Okay, so now we're going to do some problems with the arithmetic sequence to get you more familiar with it. So this right here is the explicit formula for an arithmetic sequence, and this then must be the recursive formula. So notice the recursive formula always has the previous term included in the formula. So what does a sub 1 stand for? Well, we know that 1 identifies the position, so this is talking about the first term. So a sub 1 is the first term, and d right here is the common difference. But remember, in a recursive formula, one of the terms needs to be given to you in order to continue with that. So d is my common difference, n is the place, right? So the 7th term, we would put a 7 in here, the 12th term, put a 12 in for n. So it says write the first 3 terms and give a recursive formula. So right here, the explicit formula was given, so the first 3 terms, a sub 1 would equal 27 minus 4 times 1. So the first term is then 23. A sub 2 is 27 minus 4 times 2, which is 19. A sub 3 is 27 minus 4 times 3. So 27 minus 12, that's 15. So if you notice, if we have to give the recursive formula, we need 2 things. We need to know a term previous to the first one, previous to this one, so maybe that's a sub 2. Like if we're trying to find a sub 2, we would use a sub 1, and we need to know the common difference. So a sub n would equal the first term, right? The first term is 23, plus the common difference of negative 4. Does it work? So sorry, a sub 2. So let's just check it and see if we're correct. So 23 plus negative 4 would equal 19, so yes. So therefore, the recursive formula, would be a sub n equals a sub n minus 1, whatever the former term was, plus negative 4, or in other words, we can just put minus 4. So let's try it for the 4th term. A sub 4 would be the 3rd term, which is 15 minus 4, which would be 11. So is that 4 less than that? Yes, it would work. So this right here is my recursive formula. I just have to substitute in for my common difference. Okay, next example. What position does 127 have in the arithmetic sequence below? So position, what is that talking about again? Remember, position is identifying what is n. So we want to use this explicit formula. A sub n equals a sub 1 plus n minus 1 times d. Well, we have to fill in the blanks here. We have to only have n as our unknown variable. That means we have to plug in for a sub n. Well, that's easy because 127 is our a sub n. We have to plug in for a sub 1. Okay, well that's 16. And then we have to plug in for our d. So we have to figure out what the d is. So how do we figure that out? Well, d would equal the 2nd term minus the 1st term. Or it might be the 3rd term minus the 2nd term. So 19 minus 16 is 3, 22 minus 19 is 3. Therefore, my common difference is 3. So now I just solve for n. 127 equals 16 plus 3n minus 3. I move my 16 over. 111. Oops, I have to move my 3 over. Sorry, I'm solving over here. I move my 16 and my 3 over. So I get 114 equals 3n. Divide by 3. So n equals 3 times 38. So what position? That means it's the 38th term. Right? So it's, if n equals 38, that's a sub 38, which means it's a 38th term. Okay, finally we have the geometric sequence we're going to talk about. So we see 2 formulas here. Again, this is the explicit formula, and this one is the recursive formula. So we still have g sub n, which is the nth term in a geometric sequence. We have g sub 1, which is the first term in a geometric sequence. We have r, which is the common ratio, as I talked about before. And then we have n, which tells us which term it is in the sequence. So again, over here, you have to take the term before the one you're trying to find, and you need to know the common ratio. So a particular car depreciates 25% in value each year. Suppose the original cost is $14,800. So if it's depreciating by 25% each year, then what is the percent that it's worth after the first year? So it's only worth then 75%. So my common ratio is 75% because it's decreasing in value by 25%, which means it's only worth 75% of its original value or of the previous value each year. So question A, it says find the value of the car in its second year. So what are we going to do? Well, that's A sub 2, or sorry, in this case G sub 2. We're going to take G sub 1, which is 14,800, and we're going to multiply it by the common ratio, which we just said was 0.75 or 75%, but we have to change that to a decimal. And we take that to the power of 2 minus 1, or just 1%, or sorry, to the first power. So you grab your calculator, you do 14,800 times 0.75, and we get $11,100. So it's worth $11,100 in the second year. It says write an explicit formula for the value of the car in its nth year, so that just means we're going to write G sub n equals G sub 1, which is 14,800, times the common ratio, which is 0.75, to the n minus 1 power. So there's my general formula. So in how many years will the car be worth $1,000? So we're going to substitute 1,000 in for G sub n, and then we're going to keep everything the same. We're trying to figure out how many years, which means we're trying to figure out what n is. So the first thing I have to do is isolate the ratio to the power of n minus 1. And then, or I don't even have to do that, right? I can just go straight to my calculator and I can figure that out by just setting, so actually we don't even have to do this part now that I think about it. Let's just go straight to here and plug it into our calculator. So y sub 1 is going to be one side of the equation of the equal sign, and y sub 2 is going to be the second side of the equation or equal sign. So get your calculator, make y sub 1 equal to 1,000, make y sub 2 equal to 14,800 times 0.75 to the power of parentheses x minus 1. Right, so instead of using n, we have to use x. So now we just want to find out where those two things intersect. Sorry, you need to go through and change your window. So we don't know how many years it's going to take, right? But you probably want to guess somewhat big. 20 years, 10 years, I don't know, somewhere in there. Count by ones or twos. And then the maximum price was 14,800. So I have to go up to at least 14,800. So I'm going to just go up to 15,000, count by 1,000s, and graph. So now I'm trying to find where these two intersect. So I go second calculate, I want to go down to intersect, I do enter, 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 and it should tell me, oops, there it was, sorry. It was there, it was 10.366, or about 10.37 years. So in how many years will the car be worth about $1,000? So in about 10 years, or in that 10th year, it will decrease to a value of $1,000. So that's it. Now try your assignment in class. Please ask me questions if you didn't understand the formulas or how to apply them. And hopefully as you do your homework, if any questions arise, you'll come see me. See you soon.